point, it means both the moles are same. And if you are adding more, it means this will increase. It will not be 10.5, it will be 11.5. So concentration will change. When we do the calculation, the concentration will change. So if you want to do the exact concentration, you have to get it with 1. Okay, now I am using it again. I will wash this one, right boys?
Yes.
I am washing this one, and now no need to wash this one. No need to wash this one because no reaction took place inside. Okay, I will take this one once again. Vinegar. When I am taking it, I can see it is coming out. My eyes were there. So when it reached here, I stopped. And then...
You don't need to rinse the flask with vinegar?
No need because there is water. It's a good question. There is water and the water is in the flask. No, and we are doing the reaction in the same flask.
So we don't rinse it.
No. It will increase the vinegar. I will tell you once again. I will come to your question just.
So we only rinse it if we're measuring something.
Okay. That is a good question. That, boys, listen. No need. Don't rinse the flask, because if you rinse the flask, there will be vinegar, and I am taking exact 10. So there will be some vinegar, right? So that's why there should not be anything there. When it goes, we will not blow it, and I will do 1, 2. And then don't forget to add 1, 2 or 3 drops. 1 drop is better. And now this is my initial reading. Am I right?
Yes.
For example, if it is 12.4 milli is my initial reading. And if, for example, listen boys, if for example, when you are doing, some drops are gone, so the new point will be the initial reading. Not necessarily you take 12.4 as the initial. Even if you don't like this number, put over here, remove some, look over here. So that is my initial reading. Whatever, that is my initial reading. So nobody should worry that something has dropped. So I take this initial reading. What is the initial reading now? It is 14.1. The initial reading is 14.1 is the initial reading. 14. I will remove it. So 14.1 is the initial reading. This I have kept because many students, they need to write on the file their name, ID, number. This is yours. Have you written? This file is yours?
It's mine.
Mine. So you will write over there with the name, ID, number. Otherwise, I will write on the board. Because the students are asking me, it is not good to write with this on the. So, mixing the things. All right, guys. 14.1 is the initial reading. Now I am going to ask some questions from you. I am going to use, if my first calculation is correct, if my first experiment is correct, it means that I am going to use 10.5 milli at the end, net. Is that right?
Yes.
If I am using 10.5 milli at the end, I am starting from 14.1, where I will finish. Yes, right. Where I will finish? 24.6. Right?
Yes.
I will finish at 24.6. And maybe I will not finish at that. because maybe the first time I have not done correctly. So when you are doing the experiment, if at the end, when you take the difference, if your answer is 10.6, I will accept. If your answer is 10.7, 2 degrees, I will accept. If it is below than this one, 10.4, good. 10.3 is good. 2 degree above, 2 degree below, I will accept that. Okay? Because you don't have that experience. You are students, and I can understand that there could be mistake. Understood? So that's why I am doing the way as you will be doing. I am doing the right exactly in that way as you are doing. Now, do you think I should add more of the sodium hydroxide over here?
No, it's enough.
No. I am going to finish 24.6 and it is up to 50. No need to add more. Even I can do 3 times. Okay? So no need to fill more. Sometime if I have up to here, I have to add more. Right? So now no need to add more. Okay. Here is the vinegar. Did I put the indicator?
Yes. Yes.
I put 1 drop of indicator and that's good. And now I will start it. And now listen, very important thing. Where I will finish 24.6.
Yeah.
So if I add 23 directly, will there be any problem?
No.
Why should I waste my time now? Alright. So now what I do, I will add 23 here. I will add 23 or little more like that. Is it 9 point?
Yeah.
No. Shake it.
If I shake, what happens?
Change.
Disappear.
Disappear slowly.
It is disappeared because this is not the end point, right? So now
Few drops.
I will add the end point is near. Why the end point is near?
Because it's not disappearing.
Yeah.
Disappearing slowly.
So I could have finished like that. I have experience. I could have finished like that, but you do it slowly. I will advise you, you do it in that way. Maybe I need 1 or 2 drops. That is. Well, one thing more, if something is on the wall, for example, you are touching it. If something is on the wall, you can remove it down with the water. Because water is going inside, no problem. Water is going inside.
What shall we add water?
Huh?
You add water inside it, sir?
Yes, so that if there's something is in the wall, when I touch it,
Oh.
when something is in the wall, it should go down.
Oh.
Won't it change the concentration?
Inside, everything is inside. So whatever the solution is, fixed amount, 10 milli is inside. So even I fill it with water, no problem.
Oh. Okay.
Because it is 10 milli. It will not, that amount is not going to change. Right? So this is the end point, right?
Yes.
And I have 24.6.
Oh, perfect.
I have 24.6. If your answer is coming 24.7, by the way, all answers will come different. I am going to change the whole thing when you will come. I will not leave the same. So you can copy it. No, I will change all the solutions. Now I am giving you example. If your answer is 24.6, okay. 24.7, 24.8, no problem. If it is more than that, do it third time.
If necessary.
Right? If necessary. Why necessary? Because the difference is too much.
Oh.
When you do the third time, when you do the third time, if for example second and third are close, accept them, cancel this one. Don't take the average. Don't take the average. See that if the values are close, select these two and cancel this one. If 1 and 3 is close, cancel the second one. And if the 1 and 2 are close, no need to do the third time. No need to do the third time. Did you understand?
Yes.
Okay, now since my answer is close, okay, just for the sake of study this one, when we are doing this, now let's suppose, boys, listen, let's suppose my answer is not 24.6, my answer is 24.7, let's suppose, and this will be 10.6, is that right? I am changing it, intentionally I am changing it. Okay, now, this one, please wash it. This one, and also wash this one, add some water over here. Thank you. That is the sodium hydroxide, remaining sodium hydroxide. This is the remaining sodium hydroxide. I will put all this sodium hydroxide over there, because I have finished the experiment. Now I will do the calculation. I will show you the calculation. All the sodium hydroxide is here, and don't return. Look how much sodium hydroxide, more than half is left. Did you see that?
Yeah.
So if I give you some amount, whatever the amount I am giving you, that is more than enough. Nobody could think that it is the less amount. It is more than enough. This sodium hydroxide, listen please, this sodium hydroxide should not, this sodium hydroxide should not return it back. Should not return it back over here. Because maybe there are some drops of water, maybe the concentration is changed, some contamination. I don't want this should be given to the other students with the contamination. I will give them the pure one. You take this sodium hydroxide and put it in another container. I will give you another container, and then I will purify it, and then I will make it clear, and then I will use it. So you don't return it back. Okay, now here in the burette, we have some drops of sodium hydroxide there. Sodium hydroxide, it reacts with the air, carbon dioxide, and form sodium carbonate. Sodium carbonate is a solid, white solid. So if I leave the burette like that, after like you can say 1 hour, here will be solid and it will be blocked. It will not be used. Then a lot of efforts will be done to remove it. So what you do, before you leave, you just put some water over there. Put some water like this. So all the sodium hydroxide will go down, and it will also be removed from here. When you will come in the lab next week, you will find everything neat and clean like that. A set. 2 students will do together. When you leave it, please make it like that, neat and clean. So the other students when come, they will use it. Don't forget the points. Don't forget the points. You are not going to wash it with the distilled water. The other students will come and they will wash it. So if you wash with the distilled water, that is a wastage. That's a wrong technique. Wastage is the secondary problem. Wrong technique is the first problem. So wash with the ordinary water and also wash with the ordinary water. Only burette wash with the distilled water. Okay?
Okay.
Now, this is also washed. Now listen. We have a formula, simple formula. MAVA is equal to MBVB. Molarity of acid times molarity, volume of acid is equal to molarity of base times volume of base. Okay? I have 4 things. Out of 4, I know the 3. So I can find the 4th. I will make the 4th as a subject. Molarity of base I want to find out. The other things are molarity of acid. I will give you the molarity of the acid. This one. That is why this is called the standard solution, because we know its molarity. Volume of the acid. This is the volume of the acid which I took. 10 milli. volume of the acid is 10.